So here's a walkthrough of going through Canvas and getting to MyMathLab. And here we are on my home page view from my web browser. And I do have the instructor view here, so there are some selections that have eyeballs here slashed out that you won't be able to see in your view, so just keep that in mind if you don't see that many selections. And let me just show you that this MyLab and Mastering is something that you should link your MyMathLab with. Pearson is actually pretty particular about how you log into their server, and it matters if you do it through their website or through Canvas. So preferably do it through MyMathLab and sync it all up. It'll also sync the gradebook. And let's check out then what's in MyMathLab. So then it leads us right to our course page. And normally I use a lot of the MyMathLab functions, but because of Online with Canvas, I've actually moved most of this to the Canvas selection folders and files. So the only thing that's really going to be useful here probably for you is assignments. And that'll tell you the things that have been assigned. And again, everything that has practice in it is not worth any points. It's simply for you to practice and build some confidence. So why don't we check that out? Give it a click. I'll just choose number 2. And let's check it out. Now I know there's going to be some table work in here, and that's definitely easier to use Excel with. If you don't have Excel or some type of spreadsheet, you will have to do this with your calculator. So let's check this out. Well, this first one here actually isn't a table, so I guess I'll get that out of the way. And part A. So we have our graph here, and we can blow up a little bit, I guess. Not too, kind of decent enough. And so they want to know, what is the limit of this function as x approaches -6? Now notice there's no superscript here, so that means this is a two-sided limit. And so to figure out that two-sided limit, we're going to look at the one-sided limits, the left and the right side limits. And so we have x going to -6. And let's check that out first from the left. So -6, here we are on the graph, and we're going to approach it from the left. So on this segment of the line, we're going to walk along, and as we approach -6, we'll find ourselves at a height of 0. And that's our limit. Now to do the two-sided limit, we do have to figure out the right side as well here. So approaching from the right, put a plus sign there. And we don't know what that equals yet. Let me get rid of that. And let's check that out. So -6 from the right. So now we're on this segment of the function. And as we walk along and get closer and closer to the input of -6, we find ourselves at a height of 0. And we see then that the left and the right equal. And so then we can conclude the two-sided limit exists and it is 0. And that's our answer. Stick that in the box, hit our check answer, and move on to the next part. So what do we have now? What is the limit of this function as we approach -1? Again, it's a two-sided limit. So again, we will look at the left and the right. We're going to go from -1 from the left. So here's -1 on a graph. Approaching it from the left means we're on this line. And as we come along, As we get closer and closer to -1, we find ourselves at a height of -5. And so let's check out the other side, approaching from the right. So again, -1 from the right is along this little slice here. And as we get closer and closer and closer to -1, we find ourselves at a height of -5. And we see again, both of these equal. And so then, by definition, the two-sided limit exists, and it is that number. And so we'll go ahead and enter that in. So part C. Now we have the limit of this function as x goes to 0. Another two-sided limit. Let's check that out. Going to 0, and let's do that from the left. So 0 right here on the y-axis. A little bit goofy right there. So what do we have? We have the function comes along, ends here, not included here, is included right here at the dot, not included here, and then the function goes off this way. So pretty goofy, but we can still do the limit. 0, approaching from the left. We're on this little segment here, and as we get closer and closer to 0, we find ourselves at a height of -5. So let's check out the other side from the right. So 0, the y-axis, coming from the right, puts us on this top slice right here. So coming from the right, getting closer and closer to 0, we find ourselves at a height of 1. And we see then these two do not equal. And since they do not equal, we must conclude then the two-sided limit does not exist. The left and the right must equal. So go over to MyMathLab, and here's our choice. The limit does not exist. And the last part, part D, and now we have a -0.9. So they're going to test our ability to do some approximations here a little bit. So -0.9. And let's approach that from the left. So -0.9, going to be very close to 1. So about right here. And approaching it from the left, as we get to -0.9, we're going to be right on this sliver here, which is at a height of -5. So let's do the other side, approaching from the right. So -0.9, very close to -1. And approaching from the right means we're on the same segment here. And that's at a height of -5. So we see they equal, the left and right equal. And then by definition, we can conclude, oops, the two-sided limit then exists and it equals that number. And that's our answer. Plug that in, -5. And there we go. So let's check out one of the table ones. And I want to pick this one because I do leave a note here to skip part B and C. Just practice part A here with the data table entry. And to skip it, you can just put in some fake numbers and have it fail the problem. Remember, practice is not graded, so don't worry about what your grade is on the practice. So here's our stuff. We pull over Excel. And so here's our function, a polynomial over a polynomial, so a rational function there. And it wants us to make a table of values of the output, and they are giving us these inputs. Now if you look at these inputs, minus 1.9, 1.999, and more nines, they're trying to express the idea of approaching minus 2. And this is approaching minus 2 from the right. And then they want us to estimate the two-sided limit. So in order to get the two-sided limit, we have to do the left and the right. And they're giving us the set of numbers here. Here's the numbers for the right, and then they have these for the left. And that's the table they want us to fill out. So just, oh no, Excel, okay. Thought I was going to round that to a 2 there. So there are the values they want us to input. Now, if you don't have Excel or a spreadsheet, you would have to plug these into a calculator, into this function. I'm just going to use Excel here to do that. So we're going to have x plus 2 all divided by x squared minus x minus 6. And so there's our equation, and with Excel we can just drag the equation down. And rounding numbers. There we go. And so what do they want here? They want us to round to 6 decimal places as needed. So I suppose I can I don't know if this might even fall under cheating. I don't know, but I'm just going to have Excel do it. I'll just have them round it to 6 decimal places. And there we go. So yes, it can be a little time consuming doing these tables here, so there's not too many of these problems. But I do think it's good that you see the pattern of the numbers here, so they give you more of an intuitive feeling of what the limit is, and especially infinitesimal. All right, so the moment of truth. So yeah, that did fail, and took a moment to find my mistake, and it was actually right here where my cursor is. If you want to look back at the video, you can see I had minus 2.0 here, and of course I needed to make that minus 0.20, and that change right there fixed it. And there we go. And of course those are the answers I have over here. I just didn't copy them quite correctly in that one number. So what do we got next here? So we want to estimate the limit of this function based on this table. So as the input is getting infinitesimally close to -2, what is happening with the output? Well, the output is getting closer and closer to -0.2. And so that is our approximation. So if we check out the next part here, what estimate do we arrive at if we change the inputs? So here we were approaching from the right, and now they want us to approach from the left. So I'll just change these here then to approaching from the left. And here are the new outputs. Since Excel has the equation there, just calculated that all again. And as our outputs, or as our inputs approach -2, we look at the pattern here and we see the outputs are approaching -0.2. And that is the same answer that we got with the right-sided limit. And so then we can conclude that the two-sided limit exists, and it's -0.2. And then I said just skip B and C here. Real practice I wanted to get there was just from the table. So there's two problems. There's a 9 for the practice, and I think there's 6 for the graded problems. Not too many on offer for this first part here from my math lab. And if you have some questions, let me know.